The table below shows the cost of an iPhone 4 or 4S through Sprint Mobile in October 2011, depending on its storage capacity. Create a scatter plot for the information. So here in the first column, we see the number of gigabytes of storage. And here in the second column, we see what that phone is going to cost. So from this, we already start having some information about independent and dependent variables. We saw earlier that when we're looking at tables of values or ordered pairs, what shows up first is always going to be the independent variables. So I'm going to just make a note of that here. So this is my independent variable. And that would mean that the cost would be the dependent variable. And that would certainly make sense if we think about this, which depends on the other. The cost certainly is going to depend on how much storage the phone has. So that correlates with what we had talked about in terms of dependent versus independent variables. So when I come down and take a look at my graph here, so I'm going to have to be doing some scrolling up and down. So the independent is going to be the number of gigabytes of storage, and the dependent variable is going to be the cost. So we want to be sure on our graph that we label that information on the appropriate axes. Remember, when we look at our coordinate system, the independent variable will always be measured here along the horizontal axis. So in this case, the independent variable we said was the number of gigabytes of storage. And so we want to write that down, just kind of along the bottom, sort of centered underneath the axis here. And then the dependent variable, as you remember, was the cost. And so we're going to write that, and we're going to write it sideways, which is a little bit awkward, but you get better at that with practice. And so that's going to be the cost for the phone. So we know which variable is going to be represented on which axis. The next thing we have to decide is how we can scale our axes. We need to decide if we're going to go by ones or go by twos or by 20s or 50s. And what's often true with scale is that there can be more than one right way to scale axes. There can also be lots of wrong ways to scale the axes. We want to be sure that however we choose to scale, we're spreading the information out on our graph. We want our graphs to be big and easy to read. So let's take a look at our independent variable first. So we're going from 8 all the way up to 64. And if I look down here on my graph, notice here's my origin right there. There's the origin. And the origin, we always need to have a 0, 0. Okay, so that means we basically need to go from 0 all the way out to 64. We need to fit 64 on our graph somewhere. And so scaling by ones isn't going to work. If you count up how many lines there are here, we only have about 20 lines to work with. And so if I scale by ones, that's only going to get me out to 20. I need to get out to 64. So we want to choose a number bigger than 1 for our scale, but we also want to choose something that's easy to count by. So ones certainly are easy to count by. Twos are pretty easy to count by. But if we go by twos and we only go out 20 places, well, that's only going to get us out to 40. So that's not going to be a big enough number. Threes and fours get a little bit harder to count by. We're not usually used to counting by threes or fours. Fives would be a good option for us here because that's going to get us all the way out to 64, and it'll actually even give us a little bit more than 64. So let's choose 5 for our scale along our independent axis. Now, instead of labeling every single line, I'm going to just label every other line. I'm still going to count by 5. So the first line is 5, the second line is 10. So I'm going to put a 10 here. And then the next line would be 15. The next one is going to be 20. So notice that I'm skipping a line and then I'm just labeling my numbers by tens. I'm scaling by fives. Every line represents 5, but I'm just labeling every other line just to make it a little bit easier to read. And it also saves me a little bit of time. There's 50, 60, and then out here is 70. and I could go out to 80, and I could go all the way, but I've taken care of going at least out to 64. Okay. Now with the cost, we have to think about our scale differently. Notice with the cost, we're going to have to go all the way out to just a little bit less than 400. So we need to figure out how are we going to do that on this cost scale, on this dependent um, axis here. So we have some options that we could certainly go by. Again, you want to choose things that are easy to count by because that will help us with any estimations that we need to do. We know that we're going to be needing to get up to 400 and that we're talking about money. And I'm thinking, when I'm thinking about money, counting by 25s, if I have to get all the way up to 400, that's not a bad way to go. Now, I could go by 50s as well, 50, 100, 150, 200. But if I do that, I'm not going to be using very much of my graph. I'm only going to be using up to the eighth line. That's going to get me to 400, and that's going to be the end of it. If I can stretch it out a little bit more, that's going to be better for me. So we're going to scale here on our vertical axis, we're going to scale by 25s. So the first line is 25, the next line is 50, and then 75, and then 100. 125, 150, and notice that I'm skipping line. You have to be very careful to keep skipping lines. And then 200, and then 250, and 300, still skipping lines. There's 350, and then 400. Now, don't be worried that the numbers that we've put along here are not actually numbers that we find on our table. We're able to estimate where these ordered pairs are going to go on our graph. What's important when you create a graph is that you create something that's easy for people to read and that the scale gives something that's going to make estimation pretty easy for you. So now let's go ahead and come up with our ordered pairs. So the different ordered pairs that we're going to have are, we're going to need to graph the ordered pair 8.99. So that's that first one. If it was had 8 gigabytes of storage, it would have cost $99. If we went up to 16 gigabytes of storage, it was $199. And then we also had 32 at $299. And then finally for 64, we were up to $399. So let's take a look at how those points are going to look on a graph. So I'm just going to scroll it down here a little bit so we can plot these points. So my first point is 8.99. So for my independent variable, I'm going to go over 8. So remember, here's 5 and here's 10. So we want to estimate where 8 would be. So 8 would be right about there. And then I'm going to go up to 99. And 99 would just be a tiniest smidge below 100. So it might even look like it's actually at 100. So that would be my point 8.99. And I'm going to actually label that out. Check with your instructor to see if they want you to actually label the points. 16.199, so that's going to be our next one. So now we're going to go over to 16, which is just a little bit past this 15 line. And then we need to go up to 199, which is just going to be the smallest amount below 200. So there's my 16, and then just up, but just shy of 200. So it'll be right about there. Okay. So there's 16, 199. The next point is 32, 299. So 32, we're going to go a little bit past 30. So not quite halfway between 30 and 35. So there's my 32, and then I go up to 299. And you can see you have to be really careful. It's easy for your pen to get off, or your pencil to get off line. So just be very careful. And when you actually plot that point, just make sure you're looking at the right place. So 32, 299. So if I look over here, I say, yep, that's just shy of 300. And for 32, did I stay on line? Yep, that was just past 30. So there's 32, 299. And then finally 64, 399. So we're taking a bit of a jump here. We're going all the way up to 64, so just a little bit less than 65. And then we're going to follow that straight line all the way up, all the way up, all the way up to 399, which is just shy of 400, right about there would be 64, 399. So there's the scatter plot of the information that we were given in this table here talking about cost of cell phones. Okay, so that just gives us a way of looking at the information a little bit differently on a graph rather than just looking at it from a table of values.